Let's look at 4 more practice problems. The first one is finding the second derivative, y double prime. So start with the first derivative. We have y prime equals the first term, negative 6x to the fourth power will give us negative 24x to the third power. Next, we have 3x squared. The derivative of 3x squared is 6x to the first power. Okay, so we found the first derivative just fine. Let's go on one more line and find the second derivative. So the y double prime, go from the line above. So if you're looking at negative 24x to the third power, negative 24 times 3 is negative 72. So we write down negative 72 and x to the second power. And going to the next term, the derivative of 6x is simply plus 6. So we found it. The second derivative is negative 72x squared plus 6. So this one, we were just using power rule to go from first derivative to the second derivative. Let's keep on going. Let's look at the second example. All right. Oh, another second derivative problem. We're finding y double prime. Before I start using all these rules, I'm going to go ahead and first rewrite this. First, rewrite y equals, I'll write it as 2 times x to the, look, there is 3 in the bottom of the fraction, right? So let's go ahead and bring that up and write it as x to the negative third power. Then we're going to apply the power rule. So first, y prime equals, I'm going to multiply negative 3 times 2 and get negative 6, and it's going to be x to the negative fourth power because we go down 1 from negative 3. If you do that, that's how I got the negative 4. All right, so that was the first derivative. Let's go ahead and now find the second derivative. So do the same thing from this line above. So I multiply negative 4 times negative 6. That's going to give us positive 24. And it will be x to the negative fifth power because we go down 1 from negative 4. Okay, so this is the right answer, but we can go ahead and write this in a fraction format. So I can say y prime is 24 on top of the fraction and x to the fifth power in the bottom of the fraction. So this is the y double prime. Okay. So how about some higher order derivatives? So far we looked at 2 second derivative problems. Move this a little bit over. I'll just keep it there. Make it smaller maybe. Okay, how about this? Well, this is another second derivative problem, but I have a feeling this is going to be a little more than what we just did. So second derivative, we're going to start with the y. I'll say y equals, and if you looked at this closely, this is actually a compositional function. We have an inside function of 3x squared plus 1, and we have the bigger picture. The big picture is u squared, right? And u is equal to 3x squared plus 1. So we have to use a chain rule here. Okay, so I'll go ahead and write down which rule I'm using. I'm using chain rule from section 1.7. Okay, so first take the derivative of the outside function. So just like taking derivative of u squared. Okay, ddu of u squared is simply 2u, right? So because of that, I'm going to just have this as 2 times 3x squared plus 1, that stays exactly the same. And 2 will go down 1, so the new power is 1. So I don't have to write down that 1 there. But now remember to multiply this by the derivative of the inside function. So we're going to multiply this by the derivative of 3x squared plus 1, right? So this is a good review of, oops, I forgot to put the prime notation. We're finding the first derivative. So 2 times 3x squared plus 1. And let me now go ahead and figure out what the derivative of 3x squared plus 1 is. That's going to be, now look at this one for me, focus on 3x squared. Derivative of 3x squared is 6x to the first power. And derivative of 1 is just 0. Where did that screen go? All right, 1 second, let me reconnect. The screen just went missing. All right, let's see if I can type that in. Okay, that's good now. All right, let's see if it's still recording. Yes, it is still going. Very good. So 6x, and I will close the parenthesis. But the app did slow down, so I'll go ahead and restart this. 6x, and we close the parenthesis. I'm going to go ahead and simplify this one step. I'll say y prime is equal to, I'm going to multiply 2 times 6x. 2 times 6x is 12x, right? And after that, I do have parenthesis 3x squared plus 1. Why did I use a different color? Because I want you to see this is actually a product. If they ask us to find the first derivative, then we're done. But unfortunately, this is asking you to find the second derivative. So we have to do one more step. We have to find the derivative of this, the very last line that you wrote down. So as you can see, this is a product. We have a product of 12x. Okay, that's the first part that we're multiplying. And we are multiplying this by 3x squared plus 1. So what we have to do is we have to use the product rule. So I'll go ahead and write down the product rule over here, okay? If I can get my pen to work. So the product rule is first times the derivative of the second plus second times the derivative of the first. So let me label everything that I have. So my first is 12x. That's the first part, right? 12x. So what is the derivative of 12x? That's just going to be 12. The second part, called g, is 3x squared plus 1. What is the derivative of that? That's going to be 6x plus 0, so it's just going to be 6x. So these are my product rule pieces. I will use these to find the second derivative. So here comes our y double prime. You ready? Let's go ahead and do first f times, and f is 12x, right? So I'll do parenthesis 12x. That's getting multiplied by derivative of the second, which is g prime, and g prime is 6x. So let me write down parenthesis 6x here. After that, I need my plus sign, plus, let's go ahead and put g after it. G is 3x squared plus 1, so that's that binomial. So I'll do parenthesis 3x squared plus 1. And the last piece of this chain of product rule is f prime. And f prime is simply 12. So I'll write down times 12. We can simplify this. we can definitely simplify this. Let's see if I have room. How about I make these a little bit smaller so that I can have a couple more lines? Hold on, let me go ahead and make this a little bit smaller. That's good. And I'll come back here and I will simplify this. So 12 times 6 is going to give me 72x squared. And I guess I can multiply the 12 in. All right, take a look. I'm going to go ahead and multiply the 12. I'll distribute that. And I'll get plus 36x squared plus 12. That's after distributing. And then we can combine some like terms at this point. I have 72x squared and 36x squared. So they add up to 100 and there it goes again. The screen is just not cooperating today. I apologize. I'll bring that back up. It's just like our Zoom class. Losing connections. It's snowing and raining in Fredericksburg, and that could be it. Okay, it's back. So let's see if it's recording still. It better be. Yes, it is. So I was about to write 108x squared, and then I was going to bring that plus 12 down. So that's it. That is the second derivative that we wanted to find. But you notice how this problem was much longer because we had to first use the chain rule to find the first derivative. And then when we were done with the first derivative, we had to use the product rule. This is a type of problem that I would love to put on your first exam. That sounds good, right? Okay, let's do the last one, which is the, what is this? They're asking us to find the fourth derivative. Hopefully we don't have to go with chain rule, product rule like the last one, but this one is going to be a little bit simpler. So what are we doing here? We're finding the derivative of 1 over x. But let me first rewrite 1 over x. Rewrite 1 over x as x to the negative first power. They're the same thing, right? So I'm going to go ahead and take the fourth derivative of this expression. So what is the first derivative? Let's find the ddx of x to the negative first. Okay? In fact, you know what? To make this a little bit easier, how about we give this expression a name? How about we call this y? I'm going to go ahead and just call this one y, okay? I'll say y is equal to x to the negative first power, okay? And I will find the fourth derivative of this. So if y is equal to x to the negative first power, the first derivative, we're going to bring down this negative 1 to the front, right? So we'll have negative 1 x to the, and we go down 1. The new exponent is negative 2 because 1 minus negative 1 is negative 2. All right, that was the first derivative. Let's do the second derivative. So we bring down this negative 2 and we multiply this by negative 1. If I do that, I will get negative times negative will give us positive 2. And the new exponent is 1 less than negative 2. Which is negative 3. Let's keep going. Let's do third derivative. Oh, maybe at this point, I should just draw it as y and the 3 in a nice parenthesis like that. Multiply the negative 3 by 2. So the new power or the new coefficient is negative 6 and x to the, you go down 1 from negative 3. It will be negative 4. Let's see if we can stop. No, they wanted the fourth derivative. So we go one more step. Y, or fourth derivative, is going to be, you multiply the power by the leading coefficient or coefficient. That's going to give us positive 24. And x to the negative fifth power. So we found the fourth derivative. I can say that the fourth derivative of 1 over x is equal to 24 times x to the negative fifth power, or we can put this back in a fraction format. Have it as 24 on top of the fraction, and in the bottom of the fraction, we can put x to the positive fifth power. And that's enough of those additional examples. So I will stop this video here, and I will come back for the velocity and acceleration application problems soon.